Okay, in this video I'm going to be teaching you something called the first fundamental theory of calculus, and this is basically how you define a definite integral, aka how you would find it if it's not easy geometrically like I just showed you. So for example, let's say that we have y equals square root of x, and I want to know the area underneath that line from 0 to 5. Well, the graph looks like this, like that, and basically you're looking for this from 0 to 5. But that's not something that you know from geometry how to do. So how would you do this? Well, we have this nifty little equation, which is not something you have to memorize. I mean, you will have to memorize it, but you'll be doing it so much, you don't need to memorize the formula of it. You'll just memorize the process that the integral from a to b of f prime of x, should I make that negative? Or, sorry, lowercase, f prime of x dx equals f of b minus f of a. That right there is how you find definite integrals mathematically. So, in this case, let me erase this, just pause this if you want to write this down or something, but basically, in this case, we have, let's write that we want to go from 0 to 5, square root of x dx is what we're looking for. So the first thing we have to do is find what the antiderivative of square root of x is. So square root of x is the same thing as 1/2 x, so we want to bump that up 1, so it'll be 3/2, and then we put a 2/3 in the front. That's what it is. So, for that reason, we're going to, the first thing you're going to do is do all this work, and you might do it on the side, you might do it after, but what you're going to want to do then is write down what the antiderivative is. And you don't need a plus c because we have the defining moment right here. Technically, you would put a plus c, but because you're going to be minusing it by another plus c, they're going to cancel out, even though technically they shouldn't, but in this case they do, because you want just a numerical value, so you don't need a plus c for this. And then you're going to put these brackets around it, and you're going to put the bounds right here, 0, 5. That right there is just the notation that you use in calculus, and then you simply just have to plug it in. So you would get 2/3, 5, 3/2, which I probably should have chosen better numbers, minus, but because it's going to be something times 0, you don't, it's just going to equal 0, so you don't have to put that in, but technically then it would be minus 2/3, 0 to the 3/2, which is just going to be 0, so we can cancel that. And this right here is the area underneath there, but you probably would use a calculator to reduce that, or you would, if your teacher was nice and chose better numbers, then you wouldn't need a calculator. I also want to say one more thing before I end this video. I probably should have said this before, but if you have a graph that's something like this, for example, let's say this is your graph. This right here is the natural log of x, and it asks you from like, this is the example. This is natural log of x. This is just some line, and it asks you to find the area from here to here. I just want to stress that any area underneath the x-axis is actually considered negative area. Actually, I could have chosen a better example, something like this. Let me just draw that. And if you had this right here is like y equals x minus 2 or something, if it asked you, if the line was y equals x minus 2, and then it asked you to find this, I don't know why I put that there, that was like weird, 0 to 4, x minus 2 dx. What's going to happen here is this area right here is actually considered a negative area, so it's going to subtract from the positive area. But if you notice this, you probably can figure this out in your head. In this exact one, the top area and the bottom area are equal, so this answer is actually going to be 0, because this is the positive one, you're subtracting the negative area. If this was 2 to 4, then it would just be this positive one. So because it's 0 to 4, you have to subtract this much. So I would equal 0, but to practice the fundamental theory of calculus, the first fundamental theory of calculus, I'm going to just do this problem. So, the antiderivative of x minus 2 is x squared, but with a 1/2 in front, minus 2x, with brackets around it, 0 to 4, and you would get 1/2 4 squared minus 2 times 4. And then we're going to minus the 0, but remember, this is just 0 and 0, so it's not going to be anything, because you're subtracting 0, and then subtracting, which would be adding, 2 times 0, which is 0, so it'd be this. and you would get 16 over 2, which is 8, minus 8, so you just get 0. But the point of me showing this is to prove that this area is considered negative and it cancels out, and to also show you how to use this thing again. So yeah, that's the first fundamental of period calculus, and that's how you mathematically can figure out definite integrals.